Hello, my dear friends. Welcome back to Booty Aviation Training. And right now, we are watching Navigation Numerical Series. Why is this knowledge important to you? How do the ground subjects help you? That'll be because you don't want to make a fool of yourself in the air. It reminds me of a humorous incident before I start today's lesson. A fresh student landed up at the flying club, and the CFI decided to take him up for air experience in the local flying area. And he took off after doing the external check, starting up, climbed to the given altitude, height, and reached the local flying area. After about 15-20 minutes, they decided to return to base. The CFI asked for permission to descend and return and was granted that permission. During this time, this student had convinced his instructor, CFI, that he already knows the RT and allow me to use the RT for some time. The CFI was impressed, although students are not allowed to use RT till the time they get their valid license. He said, okay, let me see. And that is when, during this short period of descent, this is when the whole lot of rigmarole and the humor started. The ATC wanted to establish his position. Where is he? Horizontal position and vertical position, so that the next aircraft can be cleared to the flight level. So he gave a call to this aircraft, whose call sign was 25. And ATC asked call sign 25, report your position. The reply he gets from this youngster is, I'm in the cockpit with my instructor. Very nice. The ATC was surprised. What kind of a reply is this? Then he said, okay, let me try another method. The controller asked him, report your height, request your height. And he replied back 183 centimeters. That is confused the controller once again. And he said, can you confirm in feet? He replied back, yes, 6 feet. Now, this is what happens when you go for the flying without having understood what is height, altitude, etc., etc. And I'm sure if he had read all these lessons, he would have done much better in his RT conversation. Of course, instructor took over and never asked him or let him speak a word till he clears his license. Okay, good. Won't like this to happen to any one of you. And if you have read these lessons, it won't happen to you. And today I'm giving you a summary of all these lessons together in one page. If you have not read these lessons, or have understood rather, you have already understood the lessons and now you are last day into the exam, then just check up, do you know this summary or not of the pressure instruments I'm talking about. Let's take altimeter, quick revision. This window is called subscale or altimeter setting window and done with this knob. And the subscale pressure is also known as the datum pressure. And the reading of the altimeter is called the main scale reading or indicated altitude. Remember a point, whenever you increase the subscale reading, main scale reading will also increase at the rate of 1 HP every 30 feet and 1 inch every 1016 feet. When you set the datum pressure as QFE current aerodrome pressure, the reading of the altimeter is called height. When you set QNH, and what is QNH? QFE converted to mean sea level under ISA, that is QFE plus aerodrome elevation in feet divided by 30 HPA. And when set to QNH, your altimeter reading is then called altitude. And when you set 1013.25, then the altimeter reading is called pressure altitude. And multiples of 500 pressure altitudes are flight levels. So if this youngster, if he had read this lesson, he would have known what is height when he's asking for height. Right. So altimeter reading is called the indicated altitude, nothing else but datum pressure from where you are measuring minus the pressure at that altitude called ambient pressure. The difference, if both are in HPA or millibars, multiplied with 30, and if both the readings are in inches, multiplied by 1016 feet. That's in the examination. In the air, the altimeter does it automatically and gives you the altimeter reading. Now, this altitude is not the true altitude. To find the true altitude, apply a correction to indicated altitude on QNH. The correction is plus or minus 4% of this altitude for every 10 degrees Celsius deviation. Deviation 20 degrees, 8%, 5 degrees, 2% correction. Deviation plus, add to the indicated altitude, deviation minus, subtract. Density altitude, correction is applied to pressure altitude plus 120 into ISA deviation. If the temperatures are high, ISA deviation will be plus, then your density altitude will be more. And a higher density altitude means the density at your altitude is less. The performance of the aircraft is as per density altitude. Then there is a barometric error correction. There are very often numericals in navigation papers for which you compare your datum pressure in the window with the actual pressure at that place over which you are flying, actual QNH. If this is high and this is low, altimeter is reading high or overreading, means indicated altitude is more than the true altitude. If this is low and actual is high, then your altimeter is reading low, low, high, low. This means indicated is less, it is reading low, but actually you're flying higher. And how much higher or lower? The difference in pressure multiplied by 30 if both are in HPA. Right, a quick revision of airspeed indicator. The ASI gives you the indicated airspeed. Read a card fitted in your cockpit, apply position and instrument error correction, generally very small, and you get the RAS rectified or the calibrated airspeed. Now go to your nav calculator, apply density and compressibility error, and you will get true airspeed. To the true airspeed, if you apply wind velocity, you will get the ground speed, and use this ground speed for calculating your timings for the distance to be flown. If you apply only compressibility error to the RAS, you get equivalent airspeed, not used in flight. Plan ES is used by the designers. And the pressure instrument, Mach meter, gives you a ratio of true airspeed to the local speed of sound. Now here, this reading 0.83 means the true airspeed is 83% of the local speed of sound. The local speed of sound is 39 into square root of the temperature ambient at the place or the level at which you are flying, and this we use in Kelvin. True airspeed is directly proportional to the indicated airspeed, also inversely proportional to density. For a constant indicated airspeed, if density increases, true airspeed will decrease. On a constant true airspeed, IAS will change directly proportional to density. If you move into an area of lower temperature, cold temperatures, cold area, the density will increase. IS will also increase for the same TAS. Now, density by itself is directly dependent on pressure, inversely upon temperature, and inversely upon humidity. Humidity we cannot calculate in flight, so we take these two factors. If density changes, okay, your true airspeed will also change and IS can change. One of them should be constant. Now, in the Mach meter, if you know the reading of your outside air thermometer called total air temperature, if it is in Celsius, convert in Kelvin, then you can find out the actual outside air temperature called still air temperature in Kelvin. SAT into 1 plus 0.2 multiplied by a constant K multiplied by Mach number square, and K were not given, treat it as 1 or ignore it. Once you know the still air temperature, you can then find out the temperature under ISA and whether there is a ISA division plus or minus, or you can use it here also, ISA division here also, for finding out density altitude, for finding out true altitude, etc., etc. Now, here is a short lesson, a revision, and so I'll not prolong it any further. And don't forget to share it with your friends, like and subscribe. And here it is, SK Booty signing off for the day. Good luck. Bye-bye. Happy landings.